hands and thumbs up so you can see.
Alright, fine. Now fold them on the sides, put them on, and look at the sun. We'll talk about it.
Kaylin, I see you, baby. You can put your thumb down. I'll see your face. We're all working.
Okay, so put them on your face and look at the sun.
Hold it. Boys and girls, take the glasses, the creases.
Baby, you're not going to be able to see the whole solar system.
Okay, so I got a couple questions.
Alright, clap twice.
Who does not have glasses?
Clap twice. Give a thumbs up if you do not have glasses.
Alright, very good. I want to see them on your face and looking at the sun, please. Hey, turn them around. The white part should be on the inside, sweetheart.
Normally you can't look at the sun.
Well, I don't want you to do that. Okay? Thank you. Now, everybody point at the sun. Okay? That way I know you're listening to me and not goofing off. Excuse me, young lady. Point at the sun, please. Okay, very good. Now, the sun is a star, right?
Yes.
Are you pointing at the sun with you? Okay, thank you. The sun is just like any other star out in our universe. You can stop pointing now, thank you. But keep looking at it while I'm telling you. The sun is just like any other star. It's an average size yellowish white star.
Yep.
And it's made out of hydrogen. Okay? Everybody ever heard of hydrogen?
Yes.
Hydrogen
Yes.
is the most common element in the universe. That's what just about everything's made out of, including you. Okay?
What? I made a.
What the sun
You're
does,
talking.
what the sun does all day long, 24 hours a day, it takes hydrogen atoms, and this is a real advanced topic, but we're going to learn something. It takes hydrogen atoms and compresses them together into helium. You've heard of helium, right? It fills balloons up and stuff. Makes you talk funny.
Yes.
Helium was discovered by studying the sun. Nobody even knew helium existed until they saw it on the sun and realized that's what the sun does, is it fuses through a process called hydrogen fusion, fuses hydrogen together and makes helium. Okay? That's something you don't learn until about the 10th grade. But in that process, it creates light and heat. Now, can everybody see the sun?
Yes.
Okay, so there's the light coming from that reaction. Can everybody feel the sun on your face?
Yes.
A little bit warmer on that side? Okay, that's the heat coming from hydrogen fusion. Just like a nuclear bomb went off nearby, that's the heat you're feeling from. On the surface of the sun, you've got billions of nuclear bombs going off every second on the surface of the sun. And that's the heat from that explosion that you're feeling. Luckily, I'll answer the question at the end. Luckily, we're far enough away so that we're not vaporized immediately by it. Thank goodness, or else we wouldn't be here, right? Does anybody know how far away we are?
93.
Oh.
Who said that? Raise your hand first. Yes?
93 million.
93 million miles. Okay? Now you see that on the History Channel or on television, and it always looks like the sun is just right next to the Earth, and there's little circles going around it where the planets orbit, and everything's nice and beautiful, right? Anybody ever seen those shows? That's not how it is. It is a violent, horribly cold, empty environment out there in space. You okay? Thanks. It's empty. Okay? We're going to talk about how far away the Earth really is. 93 million miles is easy to say, but it's hard to comprehend because it's so large. Okay? So, would you come up here for me for a minute? Would you come up here? These telescopes are going to look at the sun close up and see some really neat things. The color in one of them is going to be about like this reddish color. Now, you don't need your glasses on to see this. Okay? Would you hold up the sun so everybody can see it? Okay. Everybody looking at that sun? Everybody up here looking at the sun, Linda? Let's say the sun were this size, okay? We shrunk it down to this size. This is called a scale model in the solar system. If the sun were that size, the Earth would be this size. Can you see this? See this little bitty dot right here?
Yes.
Everybody see that? That's how big the Earth would be next to the sun if the sun were that size. Now I'm going to put it about the right distance. What do you think? Right about here?
No.
Right here?
No.
Right here?
No. Yes.
Right here?
Yeah.
Okay, well, we're going to learn something else today, too. Would you hold up the Earth for me so everybody can see it? Would you walk with him when I ask you? Start walking that way. Hold up the earth so we can see it though. We'll talk about the distance, what 93 million miles really is. Alright, stop right about there. Now hold up the earth so we can see it. Okay, you believe it's that far away?
Yes.
Well, let me tell you, that's where the first planet in the solar system is. Who knows what the first planet's name is? Mercury. Exactly right. That's where Mercury is. We ain't even got to anywhere near the Earth yet. And remember, the sun is this size in our solar system. Keep on going. All right, we're slowly edging up on the second planet in the solar system. What's the name of the second planet?
Venus.
Venus. Right. That's about where Venus is. Go to your right a little bit. Straight. All right, now we're getting close to the Earth, so I can start seeing the United States. I can see Georgia now. All right, go a couple steps that way. All right, now back a couple steps that way. I'm just messing with you. All right, now hold on to Earth. That is how far away the Earth would be if the sun were this size. Everybody understand that? It is an enormous distance. I mean, it is might as well be infinity. Okay? If you're not paying attention, then see you later. Okay. Thank you.
Everybody should be on their bottoms. Crisscross applesauce. Even I'm on my bottom.
Now,
Thank you.
if we were to try to go to Jupiter or Saturn or Uranus, or what's the next planet anybody know after Uranus? Neptune. Very good. You guys are blown away the 5th grade. Okay? If we were to try to show you where Neptune would be, we'd have to go all the way to the moon almost, compared to the sun being that size. The solar system is extremely big. And that's not, thank you, sir, you can say that. That's not even a speck compared to the distance to the next star. Okay, so I just want you to understand how large these things are. Television has a way, and the internet has a way of making things look a lot smaller than they really are. The solar system is enormous. Okay? Now, who's got a telescope at home? Anybody? If you have a telescope at home and you point it at the sun, does anybody know what happens? What happens? It will melt immediately. And then your eyeball will melt immediately too. Okay? So don't mess around with your home telescopes. These are specially designed to look at the sun only. You can't see anything else with these glasses or with these telescopes. Because that's all I study. I'm a solar physicist. Okay? I study the sun and the physics behind the sun. We already learned about hydrogen fusing into, remember what it was? Helium? Causing the sun to work? Alright. You see a sunspot? That's good, because there's several on the sun right now. We're going to see them close up in a minute. Alright, now, don't point your home telescopes at the sun or you'll be sorry, because that'll be the last thing you ever see. Okay, don't mess around with that. Now, if you're not going to pay attention to this part, you're not going to know anything about how to use the scope. So everybody look at me. If you got on glasses, look how handsome I am first. Can I get a round of applause how handsome I am? Just make sure you're looking at it. Now, close one eye. Does anybody have more than 2 eyes? Anybody got 3 eyes?
No.
How about 4? You got 4 eyes? Well, close 2 of them if you got 4 eyes. Now close 3 of them. Anyway, the point is to have 1 eye open. If you're wearing glasses and you're not comfortable doing that, just put your hand over your eye. That's fine. It works better if you can just close one of your eyes. Okay, stand up. Now, stand up. This is going to be my make-believe telescope here, okay? Don't move the telescope. Now, I got 1 eye open, right? Everybody looking at me? When you get up to the telescope, there's 2 telescopes to look through visually. You take your open eye and you put it just like that, as close as you can get it without touching it, okay? Because if you touch it, you're going to knock it off aim and you won't see anything. Just put your eye in there as close as you can get it, just about like that, okay? It helps a lot too if you put up your hand and block the sunlight from coming in, because it makes it easier to see. But just don't grab the scope, because if you grab it, you'll move it off aim and you won't be able to see anything, okay? That's how we're going to look through them. In the first telescope, you're going to see an image that looks like this. This is the white light coming from the sun, and these are sunspots. All these spots are bigger than the Earth, way bigger than the Earth, okay? In the second telescope, you're going to see a red image. It's just the red light coming from the sun. It'll look kind of like this, and there's some flares and things coming off the edge of it, okay? Everybody good with that? Now, do you see that silver blanket down there?
Yes.
That's the third thing we're going to do. I have cameras connected to those telescopes showing you a close-up live image of the sun's surface. This is not the internet or TV. This is a real-life camera looking at the sun's surface.
Awesome.
And the way you look at it is by lifting the blanket 2 or 3 at a time. Just stick your head under the blanket and look in there and you'll see. the blanket is so that it blocks the sunlight so you can see straight. Does anybody have any questions or not understand what we're doing? Yeah.
What if we had a telescope at home, we put these over?
Your eye will be immediately melted and your telescope will be immediately melted. It will melt right through that plastic. Okay?
So this?
Because it'll concentrate all the sunlight in one spot and it will immediately set your head on fire probably. Okay.
I'm sorry, I can't hear Chloe's question, and I might have that question. What did you ask, Chloe?
The glasses say eclipse shades because they're originally made to view eclipses, but you can look at the sun anytime with them also. Yes, ma'am? How hot is the sun? Good question. Anybody know the answer? Very hot. The sun's surface is about 10,000 degrees Kelvin, okay? And the sunspots are about 6,000 degrees Kelvin. Either one would immediately vaporize you. The core of the sun, where the hydrogen... Put my shoes on. I'm trying to block the sunlight from your eyes. Inside your face, there you go.
You good? Okay, awesome.
Wood. We got
I was able to do it last year, and it's just so cool, you know.
White ball in there.
We stand up in front of
Guys, come here.
The sun is making me... This is starting to not look like a line. That look like a line. I'm about to see that.
That's your turn again.
What's your question?